The electrolysis on part 5 talked about electrolyzing aqueous solutions, and the solution we looked at was sodium chloride solution. Let's have a look at another solution now. Let's have a look at copper sulphate solution at CuSO4. Now let's draw a nice big beaker and let's put an anode in, and let's put a cathode in. Okay, and there's the top of the solution. Now, copper sulphate, what ions are in copper sulphate? Well, there's copper ions, which are Cu2+, and sulphate ions, which are SO4 2-. Now that's from the compound there, but also, since it's an aqueous system, you'll also get hydrogen ions from the water and hydroxide ions from the water. So we've got these 4 ions present in solution. Now I'll try and draw those quite small, that my voice should be all you need. So you've got these 4 ions in solution. Now, as we talked about before, the positive ions move to the negative, and the negative ions move to the positive. As we said before as well, the ones that go to the positive, the one that goes to the anode, are known as anions. And the anions in this case are sulphate ion and the hydroxide ion. And the cations are copper ions and hydrogen ions. Okay? Now, what we've got to do is try and figure out which ones of these ions get discharged using the rules we talked about last time. Very straightforward. Let's do the cation first. It's the least reactive of the 2 species. Now, in this case, copper is actually below hydrogen in the reactivity series, so copper is discharged. And how will it discharge? Well, like this: Cu2+, aqueous, plus, in this case, 2 electrons, will give Cu solid. So copper will be discharged at the cathode. And what you'll actually get in this case is copper will be deposited on the anode. Okay, it will actually get thicker with copper. Oh, by the way, one thing I haven't mentioned is in this case we're using carbon electrodes. Okay, not copper, we're using carbon to start with anyway. So we get copper deposited at the cathode, and it gets thicker. The cathode gets thicker. Alright, as it gets deposited on. Right, now we've got a choice between sulphate ions and hydroxide ions. Now, as I said before, all you have to do here is figure out, is there a halide present? And in this case, there isn't a halide present. So, if no halide is present, the hydroxide ion gets discharged. Okay? Now, the discharge of the hydroxide ion is quite complicated, but it's just got to be learned. No other way. It's 4OH- aqueous gives 2 waters, liquid, plus oxygen gas, plus 4 electrons. Okay, that's how the hydroxide ion becomes discharged. Now, a bit complicated, yes, but it's got to be learned. So what happens at the anode? Well, we'll see bubbles, and the bubbles will be oxygen. Okay, and water is also a product of the electrolysis, so that must be stated as well. So the 2 things produced are oxygen and water. Okay, now a couple of interesting things about this electrolysis. Let's have a look at what ions we started with at the start. We started with copper ions and sulphate ions, and hydrogen ions and hydroxide ions. Which ones went? Well, copper went at the cathode. Hydroxide ions went at the anode. So the solution slowly turns into H2SO4, sulfuric acid. Okay, as the electrolysis proceeds, it turns into sulfuric acid. Another interesting thing about this particular electrolysis is at the start of the electrolysis, okay, it was this copper sulphate solution was a beautiful blue colour. Okay, now what causes the blue colour? Well, it's this ion here that causes the blue colour in aqueous copper sulphate. Now, as the electrolysis proceeds, we're taking these ions out of the solution, and so as they come out of solution, the blue colour will fade, and so eventually the blue will fade to colourless. Okay, so that's the electrolysis of aqueous copper 2 sulphate using inert carbon electrodes. Okay, very simple. We've done sodium chloride now, and we've done copper sulphate now, but the rules are exactly the same for all other electrolysis of aqueous solutions using inert electrodes, carbon electrodes. We could have also used platinum. That's another type of electrode we could have used. Okay, it's more expensive, so we don't.